Thank you, Mike. Hello, I'm delighted to be here for the second year. ASPRS is a great organization. It's a good crowd. Again, a round of applause to Becky and Alan. It was such a wonderful job. To us, it's always an interesting experience to come to Reno. It doesn't have to be at nighttime. There's all kinds of characters out there. It's really, I have a little booth here with my colleague Andrew, and it's interesting to see the evolution from last year and this year. Last year was a lot of new people wondering what UAVs can do, what are the accuracies they can obtain, you know, do they really need to spend a lot of money, and why, and how can they implement all of that. And this year it's shifting a little bit in a way that a lot of people know about UAVs. They've done their homework. Some of them might already have purchased some equipment, done some assessments of stockpiles and whatnot, and much more informed users who really are looking at, you know, what are the ROI they can do, and what type of site or what size of site do UAVs really make sense for them. So it's really good to see that the sophistication of how to use UAVs much beyond the UAV itself and the hardware is taking place. Today we will talk about vertical structures. The reason we're talking about that is we've had a lot of interest about cell phone towers, electrical towers, and all types of high vertical structures. And it's something extremely challenging to do in photogrammetry. Traditionally, it's something done with laser scanners and LiDARs from helicopters or from the ground. And those need a lot of stations from the ground, and with all the obstructions of the different components of a tower, it takes a long time to do it with a LiDAR. And for a tower which is pretty high, often the LiDAR or the laser scanner cannot do it well, especially if you don't have backoff distance enough. So we'll show you it's possible to do it with photogrammetries from UAVs, although it's not easy, but it can be done. Very quickly about Pix4D, founded in 2011 out of EPFL University in Switzerland. It's a spin-off after 10 years of computer vision research. We now have 40 to 45 people. We have actually 2 field offices, one in China and one in San Francisco, a couple of hours away from here, where we mostly do technical support and some business development as well. You might have heard about Pix4D through a UAV manufacturer. And as a matter of fact, a number of UAV manufacturers now realize that they need to offer a solution, not just a piece of hardware that really works well. So more and more, the UAV manufacturers are moving to providing an entire solution that includes some hardware, some software, maybe some training. So we do have a lot of partners, but mostly we work with end users, and our customers are the end users, some of you in the room. At the core, the software solution of Pix4D is to automatically take hundreds and thousands of images coming from non-metric cameras, what some of you will consider low-grade cameras, low-grade optics, any focal length, any orientation, no IMUs, and we process all of that. We triangulate, we do the feature matching, the calibration. We create a point cloud from which we derive 2D and 3D and many different formats. When it comes to looking at vertical structures, you know, so beyond the traditional topo map, we do provide guidelines for how to capture the images, because really the way you capture the images is really critical, because that's the main source of information that we have. So for an urban area where you have a lot of shadows, a lot of obstructed areas, a lot of facades, we recommend to do the crisscross pattern, looking down. Of course, it depends on the field of view of the camera. And here you have an example of a mesh. This is actually the EPFL campus. And it works pretty well. When it comes to looking at a single building, we recommend to use oblique angles for the camera and really going around the building and really get a lot of details. So here you have an example of a single building with a solar panel on top. You can see how many images there are around, because we do need a very high amount of overlap. When it comes to towers, we do recommend different flight plans, some of which are harder to do, especially if you have wires coming through, such as an electrical tower. Going around the tower adds specific different altitudes, as well as doing vertical flights around the tower. So again, lots of images. Last year we did a major project with a university in Rio de Janeiro and Ariane Labs, in Canada. This is an icon of Brazil, Cristo Redondo. It's a huge statue. I'm sure some of you have been there. It's a very challenging environment, and there was no as-built model, very well done, of that icon. They have dry laser scanners. They could not do it because it is sitting at the top of a mountain. There's not enough standoff from the statue itself. And a couple of years ago, there's always lightning striking the statue. A couple of years ago, they lost a piece of the statue. That, of course, they like to preserve that icon for a long time. So we decided it would be a challenging project that would also enhance the level of innovation and performance that help our software become better. So we went there. We only could fly about 45 minutes in the morning before the tourists would arrive. Ariane Labs flew daily. The weather was absolutely horrible. It's at the top of a mountain, crosswinds, unpredictable winds, a lot of humidity, lots of rain. In addition to that, the statue has a massive amount of steel to hold it, and that had an effect on some of the components of the UAVs. So we did a number of flights, and we were able to put in the software, work on it quite a bit. It's not a one-click button to do this type of project. And in essence, we were able to make it work and have, this is a point cloud, polarized point cloud from RGB Images. Everyone was happy, the church was very happy, they care a lot about the statue and how we would treat it. And the level of details is really outstanding. I mean, there's no way you could have that with a stationary laser scanner or going over with a helicopter quickly. You can see some of the details of the statue itself. So really amazing things that you can do with a bit of work if you want to make it work. And UAVs were really the perfect tool to do that. So a company called Skydrone Technologica in Brazil has been serving a lot of engineers for a while. And they had a project is to inspect a chimney stack. Over 100 years old, needs to be inspected for safety. And they saw the project we had done with the Christ, and they said, well, let's try it this time to do a vertical structure. And they were able to acquire images and do it. And they were very happy, but more importantly, the customer was happy. So in general, they would provide photos of the chimney. The civil engineering firm that had commissioned this project was really happy because they actually really liked the fact that they can really navigate around the 3D model, in addition to getting the same photos as they would have. In addition, what they had not realized is instead of just getting the chimney, they were getting what is around the chimney that has an impact on it. So imagine you have a gutter that has been mispositioned and is creating a lot of water on the base of the chimney that would have an impact that if they had not had this 3D model, they would not have done. So they were really happy. What they had realized is the upper tier of the chimney needed actually some work, and therefore measurements to be able to plan the work. The chimney is about 1,000 miles away from their office, and instead of flying and getting another round of surveyors, maybe other equipment, they were able, right from the office, to make some measurements from the point cloud and the 3D model and the photos, and actually already start planning for the repair of the chimney. So they saved a lot of time, a lot of money, and had the SkyDrone technology had not had the idea to do it with photogrammetry, it would not have happened. So, moving down to what you guys are very interested in is, what are the challenges first of doing cell phone towers and electrical towers and radio towers? Is a lot of the components are really, really thin. And that's really challenging for a photo, especially if you need to keep a standoff from the tower itself. In addition, there's all kinds of reflectivity. There's metal, the sun reflects, there's been paint over, and you can see through, so it makes it somehow harder if you were to look at an image in 2D to really understand the depth that you have. So what we recommend is to have a good flight plan, so either a good pilot or a good autopilot to be able to help you do it well, following some of the guidelines that we provide, and take a lot of images. I mean, at least 200 images or more. And the images need to be of high resolution. So that's where not only the number of megapixels, but also the dynamic range of the camera itself is important. And the reason we recommend to look at an oblique angle down instead of up. So you would think if you look up at a tower, you can look at the features with a high contrast, and therefore it would be better for the software. And actually what we have found is if you tilt the cameras down, you're able to capture some of the ground around it, and that acts as an anchor to tie a lot of points of the structure itself. So it's very important to have that. And then you can have a beautiful point cloud. This is a cell phone tower from photos, and everyone is happy except not, because a lot of engineers and people doing inspection and maintenance on the towers, they don't really know what to do with the point cloud. What they really want to do is an inspection. So what we have found out is actually going from the photos to a point cloud by triangulation. We can actually go back from a point to the photos, and in this way provide a 3D model that give you a good framework for organizing all the photos and be able to see things in 3D without having to go through GPS logs or without having to go through a video. So the 3D model can actually provide you with a very good way to organize all those photos and therefore look at the assets with very close inspection. So we go through the example using the same tower. So here you just click on a point on the point cloud, and through a feature that we call the ray cloud, it will show you every ray of light, if you want, of that point seen by all these images. So you can see here, really hard to read that point is seen by 135 images, and that point is a little green cross that's hard to see on the images themselves. So imagine you are looking at a part of the tower, and you're like, oh, hold on a minute, I have a nest. So that can be a problem. So you want to know more, right? You can't just report there's a nest. And if you were to look at it from a LiDAR perspective, this nest would be like a horrible mess. So you actually need the images to make sense of what you're looking at. So clicking on that nest, you can see here, you have the different views that I took from different photos of that nest. So you can see really how it is related in relation to each of the antennas. How far is it going really, and what are the wires? It's really touching to really be able to say, do they need to remove the nest? Is it going to cause a Can it cause a short pretty soon? What is the impact of that? In addition, we can do measurements from the photo itself through the point cloud. So, okay, you have a nest, then what? How big is it? So in this case, we can calculate it is a little shy of 2 feet. Then, I mean, possibly you could estimate the weight and say, look, this is how much weight we have on it, and that's the impact that we have. And, I mean, what we're watching here is photos. But to be able to really pinpoint at specific features of the photos, that can be problematic or not, depending if you are trying to see if the tape is correctly attached or look at the serial number. But all of that is referenced through the point cloud that we had generated. So what we found out is actually the point cloud serves as a reference model for a lot of the images that can be used for inspection. Here's the photo number that can be sent to someone. So as a conclusion, where we're moving is really from 2D mapping that can be done by UAVs very, very well. A number of users have used that for years, to doing more inspection, more 3D, more asset referencing. What users need at the end is a solution. So whoever are the technology manufacturers, it's really good to work together to really offer something that really works well, and is easy to use, easy to be supported and to be repaired. What also I've seen is professionals are using UAVs. It can be all kinds of professionals. It can be a one-man shop, it can be an enormous enterprise, large cap company. And they will use a lot of different brands of UAVs, and they each have different requirements. But at the end, I think the end users are now realizing that UAVs are really another tool. As a matter of fact, I have a surveyor who I'm in touch with pretty often in Texas. And he's doing a lot of surveying. He has 3 UAVs from $2,000 to $80,000, depending on the type of accuracy that he needs and the size of the job. And I asked him, I said, what do you have in your truck? He says, I have a UAV all the time. It's there. It's like next to his hat, hard hat, next to his tape measurement tool. It's another tool in the toolbox. He's keeping it all the time. All the time. And I think that's really where we're going is UAVs are just another tool in the toolbox. They need to work well, and they will be more and more integrated with other tools, whether it's LiDAR, it's GPS, it's RTK, it's remote sensing images. That's really where this interaction is all going. And it's really good to see that UAVs are becoming better, becoming easier to use by larger companies who really are looking at it from a professional perspective, who have the funds to be able to do that, do things in volume, keep manufacturing of higher quality, and also being able to support. So I have 4 seconds over time, and I'm actually done. If you have questions, it's actually a very good knowledge base that we have on our support site, not just for Pix4D, but for a lot of photogrammetry questions, structural motion. This is, I call it the gold mine. I use it every day myself. It is, the more I'm in UAVs and geospatial, the more I feel I need to learn. So thank you so much for your attention.